we have an important theorem in mathematics which states that the square root of any prime number is always irrational. Today we are going to prove how root 3 is irrational, but this question can be molded to any prime number. So we are going to prove how root 3 is irrational. We will prove it by contradiction method. We will assume that at first let root 3 be a rational number. Assume root 3 be a rational number. We have assumed that root 3 is a rational number. That means root 3 can be expressed in the form of P by Q, where P and Q are co-prime integers and Q must not equal to 0. That is the condition for rationality. And here we have taken P and Q are co-prime integers. Co-prime integers means the HCF of P and Q is equal to 1. Means that P and Q have no common factor other than 1, right? After solving this, we get P is equal to root 3 Q. We have to remove this root, so we will take squaring both sides. We get P square is equal to 3Q square. At this step, we have written P square as a product of 3 and Q square. That means from this step, we can conclude that 3 divides P square. We have an important result which states that if P is a prime number and if P divides the square of an integer, then P divides that integer also. Here P is a prime number, it divides the square of an integer, which implies that 3 divides P also, right? That means if 3 divides P, then P can be written as 3 multiply some integer, where M is any integer. Since 3 divides P, that means we can express P as a product of 3 and some integer. Using this, in this original equation, name this equation as A, we will get 3m whole square is equal to 3q square. After solving this, we get 9m square is equal to 3q square. Further simplifying it, we get 3m square is equal to q square. Or we can also write it as q square is equal to 3 into m square. Here q square is equal to product of 3 and m square. That means we can conclude that 3 divides q square. Since 3 is a prime and 3 divides q square, by the result we can conclude that 3 divides q also. From these two equations, we deduce that 3 divides P and 3 divides Q. That means 3 divides P and Q. That means P and Q have 3 as a common factor. But we have assumed that P and Q are co-prime numbers. That means they have only that is 1 as a common factor. But from here we get 3 divides P and 3 divides Q. That means P and Q have 3 as a common factor, which is a contradiction. to our assumption that P and Q are co-prime numbers. That means our assumption is wrong. What was our assumption? Our assumption was root 3 be a rational number. That means since our assumption is wrong, therefore root 3 is an irrational number.